Hi everyone, welcome to the bi-weekly PR review club. So in this PR review club, we'll be reviewing the PR 31492. Okay, so the motivation of this PR is basically, yeah. So what happens was the bind is an RPC flag which actually binds your Bitcoin node to the available interface, okay, network interface, so that it can listen from that interface. Uh, like it can listen anything like all the P2P messages, transaction, and all that stuff. So the problem was identified by Vasil. He actually discovered that the discover function, which actually manages the searching of all the available interfaces in your system, is not executed when we are specifying the interface as 0.0.0.0 or double semicolon, not semicolon, double colon, which 0.0.0 is uh, specifies IPv4, which means that uh, like uh, it will listen on that on all available network interfaces, okay, IPv4, and double colon specifies on all interfaces, available interfaces, that should be IPv6, okay. So the issue was basically the bind on any like this variable was actually being false when we specified this like this interface, okay. So because this like 0.0.0 specifies that it should listen to all available interfaces, okay, but when this was set by the user, then it actually doesn't work. I mean, the discover function was not executed and it was giving some error, okay. Same goes for the double colon, okay. And yeah, that was the issue, and this PR tries to fix that. And we'll just see the commits, the code changes, how it was fixed and what all has been fixed. So basically in the first commit, the changes that has been done was in the C++ code, okay. And in that C++ code, there was two argument that has been added, not added, I mean, that was actually previously it was after all the discover function was executed, it was specified here, but this was changed to before the discover function or the the bind on any value. This variable was actually checked. Okay. Previously, it was after that. After it was checking, it was specified, but instead it should be before that. Okay. So will this bind on any value? This is actually a boolean value, and if the bind is actually empty, or if the white bind is actually empty, then bind on any value is actually true. Okay. So if we specify 0.0.0.0, or if we give double colon, then this is not actually false. This is not, I mean, this is not actually true. This is actually false. Okay, because it's not empty. So this was false, and because of that, the discover function was not executed, because bind on any value would become false. Then show you that. Wait. Yeah. So okay. Okay, this is actually the changed code. I'll just show that from here. Okay, what happens was this actually became false because we are specifying 0.0.0 or the double colon for IPv6 and 0.0 for IPv4. This was false, and because of that, the discover was not executed because the bind on any was actually false. Okay, but instead it should be true because 0.0.0 specifies that it should listen on all available interfaces. Okay, so that was the core issue. So like this was added in the init.cpp, that when the bind on any value is actually false from this part, okay, then with the or is equals to, what happens is bind addr dot value dot is bind any would become true because we are already giving 0.0.0.0, so that this becomes true, and this becomes true, and with or, and the overall bind on any will become true. So that was the small change, but I would say this was the effective change, and similar goes for here as well. Yeah, and this one was for the tor. If user specified uh, something like is equals to onion, okay, then that should also be listen. Like all the tor interface should be the available tor interface should be searched and listen. I mean, basically the discover function should be executed. Okay, so here we are just adding, like if the string contains is equals to, that means the user specified is equals to onion. Okay, so yeah, with this then this function was checked whether that bind on any value, and if it was empty or onion binds was empty, then it would execute the discover function. Yeah. Same goes for here. If the default onion target has been found, then yeah, it would redirect to net processing.cpp, process all the listen to that onion interface, and uh, listen to all the P2P messages that has been received from other peers. So yeah, this was the change in the first commit. The first commit was basically change in the uh, core code, basically the CPP code. Okay, we'll just see the next commit. So next, commit was change in the functional test. Like actually, Vasil, he actually found that from the functional test. Okay, in functional test, it was found that when we were using the bind 0.0.0, he actually modified the functional test and tested whether the functional test would pass or not, or if it was specified IPv6, then if that functional test would pass or not. So yeah, the functional test has been modified so that if 0.0.0 is specified and if certain bind port is specified, if this is actually the interface, and this one is the port, okay, for the testing purpose. And if IPv4 or IPv6 listen on any address interface was provided, then whether that functional test would pass or not. That was the change in the functional test. And apart from that, yeah, this whole code, it actually set up the networks, and in the networks it explicitly mentions it actually checks whether that node has explicit bind or not, like if it has particular interface or not, if it has the port available or not to bind. That what this code does. And after that, it just verifies whether that address has been found from in that interface. It might be possible that the node would it doesn't it the user specifies the bind argument with 0.0.0.0, and the node doesn't have any interface. Okay, so this function just verifies that whether that address is available or not. uh yeah, this was it. And we'll just see what actually discover function does. Okay, I'll just show you that. Yeah, this is the discover function. Okay, so discover, it actually searches, or you could say discovers all the available network interface. If the user didn't specify any network interface, then it should execute. If the user specified certain network interface, for example 127.0.0.1, then it should search for that available, whether that network interface is available or not, whether that port is available or not. The discover function is responsible for that. So discover, this is the discover flag, whether uh, this yeah, yeah, the discover is true. While building the Bitcoin D, there is not sure there is a C++ flag which you can specify for discover. Okay, you need to specify that before building this, before building the Bitcoin D. I mean, by default it's set to true, but even if you just set it to false for security or privacy concerns, then this function would not be called. So that's what the f discover flag does. Okay, and after that, this function, it calls the get local address, which search all the possible. It searches all the possible addresses or ports or interfaces in the node. Okay, so this is the preprocessor directives. If the system or the node is basically Windows, then it would execute this function. If it's Linux, then it would execute this one. So mine is Linux, so that's why it is not actually, it's the unhighlighted part. Okay. So in Windows, there is a function called get host name, and what this function does is basically it searches all possible network interfaces, ports available. This is actually the OS already has. Okay, the get hostname is for Windows, and for the Linux, it has get if address, addrs, and this one is true for like Mac OS as well. And with this function, it will check whether that node has all the possible or all the available network interfaces or not. If user specified a certain network interface, then that would search according to that. If it doesn't specify, then it would search everything. And yeah, that was it about this get local addresses. Uh, Apart from that, uh, so first, we'll just see how we'll just debug discover. Okay, using LLDB. I'll do with LLDB in my machine. You can do with GDB as well. So we'll just see that how when was discover called or when it would call. Okay. So I'll just use LLDB. I've compiled the discover bind, uh, the branch from that PR. Okay. So we'll just set a breakpoint at first. We'll set two breakpoint. The first one would be discover, and the second one would be get local address. We just want to see where when is discover called, and when is like what happens in get local addresses. What all network interface has been searched, and we'll print. We'll see what all interfaces has been searched and see. Okay. So I'll just set the breakpoint at line 3124. This will be our first breakpoint. We'll set up another breakpoint, this net if.cpp. At line 275. Now we'll just run the Bitcoin D, and this should break at the first breakpoint. Yeah, the first breakpoint has been received at the discover. Is line 3125. Okay, this at this line it has been breaked. Okay, we'll just step over into that, and yeah, 3126. Yeah, if you see here, we just reached at 3129, line number 3129, which is this one, which is entering into the for loop. And after that, it should enter into the get local addresses, because we have also set the breakpoint at get local addresses, because we want to see what all addresses has been received or searched in the get local address function. Yeah, so breakpoint 2.1 has been received, and it the like it enters the function get local address function, okay, inside this native.cpp file. Yeah, at line 276, it has been breaked at line 276. We'll just step over into that. 277 again, 285. Yeah, now it is searching in my host machine, because this machine is actually Linux. So this wasn't executed, because this one was for Windows 32. Okay. Yeah, 286, 288. We just want to reach at 300 or 302, because like we want to see what all addresses has been searched. Okay. Just execute 294, 286. This, if you see here that we are again going back to 286, 287, 289. This is because we are actually searching all the possible interfaces in this host machine. We reach 296. Yeah, we reached 296. Yeah, we reached 299. Okay. So what this function does is actually there might be a lot of like you could say ki, uh, garbage address as well. Okay, your node has searched, because we are just specifying 0.0.0, and it might has any garbage value. Okay, so this will just free all that garbage value, and my address is actually it will actually, yeah, this it is actually searching from the get if address addrs. Okay, then it will just like free all the address, the garbage address. Okay, we just don't want that. We just want to see what all possible IPv4 and IPv6 interface is there inside this host machine. Okay, that this node would listen to. So we reached at 303. Now we can just print the address. Yeah, you can see here that we just found two address, that is one is IPv4, the other one is IPv6. Okay, so yeah, the other one is the first one is IPv4 and the other one is IPv6. Yeah, this was it, and we should return now to the discover function. Yeah, this actually was returned at the discover function, and yeah, that was it. Just exit this LLDB. Let's get back to this review, and any question till now, if you have any. I mean,
None from my end.
okay, okay. So we'll just move forward then. And also, one popular comment from this PR is that, okay, let's try to run this the test that has been also updated. So we'll see what has been updated. Okay. Yeah. So before testing, you need to set up this. What we are actually doing here is that dummy network interface. This one is the network interface. Okay, that I have created in my local machine. Okay, with name as hello dummy. Okay, then I'm starting up the network interface. I just want to create because for testing purpose, you need to have some network interface. Okay, if you don't have this network interface, testing network interface, then this functional test wouldn't work, uh, because this functional text it wants that it wants that you should have some dummy interface. Okay, because it doesn't want to test on the uh, the 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 main interface. Okay, which is the main interface in Linux is actually just the hello, or in macOS it's hello 0. So we are just setting the dummy interface for this functional test, and inside that dummy interface, we're just specifying two IP addresses. First one is 1111 and the second one is 2222. Okay, and and we are both starting up that IP addresses. Then we'll just build this test. So I'll just copy this and uh, just a second. Yeah, don't know why it's not working. Mm, just a second. I guess I need to give it the root permission. Don't know what's the issue. Mm, This should work.
I think you should run the command line by line, like not pasting the whole thing, but sudo in first.
Mm, I guess I tried that. Okay. So I guess I already
It
created
already
that.
exists.
Yeah, yes. So I think I'll just start up this. Oh, okay. Just a second. I'll just change this review. Um, I guess I already created that, and that's why it's giving me this issue. Okay. Yeah, this the dummy interface has been started up. So now, what we'll do is after starting up, we'll just add two IP address inside that the dummy interface, 1111, and start up that IP address. And the second one is this one. Okay. So yeah, this has been up. Okay. So now let's run the test. Functional. What was the name of the file? Feature bind port discover. Okay. I also need to specify two arguments. One, I have one, and Let's see what. Okay, first we need to provide the argument, then we need to specify the file. So yeah, you can see that the test has been passed. If you don't specify the arguments, then this will basically skip. Okay, and if we don't have, suppose we don't have the network interface, uh, like this, we just down it, shut down it, and then we'll just run this. This should probably fail. Yeah, this will fail because we don't have that network interface, the 1111 and 2222. Because if we see in this, um, just a second, in this feature bind discover. Okay, so if you see here, then it's just specify that we need to have this interface and the 1111 and 2222 available, or basically it should have the your host machine should have configured with this interface. Okay, if it's not available, then this test would basically fail. Okay, yeah, that was the like the minimum requirement for this, like this functional test frame, the functional test. Okay, and yeah, any question till now? I mean, I'll just shut down this.
So, other than UVic, if anybody else got an opportunity to review the PR or get the opportunity, do you all have anything to share? Anything to add to what he said? Your observations, your inferences after going to through the PR? Would anybody like to share with us?
Yeah, I was like curious about like in the functional test, we would check if we have the like required address that we have specified. And, like sometimes, yeah, sometimes it can be case that our port that we are trying to use, it might be like being used by some other process, and like it might be busy. So like uh, if like we if the port is like being used by other process, would the test fail, or like will normally what happens is that if a case like that happens, then we forward the process that we are like trying to run on this port to other process, the new one, and like then the test goes on, which is like generally the case with other other projects, and like what happens like in the case I was just a little bit curious why like what would happen in the case in the test.
Okay, so actually, like, if you see here, what happens is I am actually creating a dummy interface. I'm not actually using the real one, like that is probably listening to some services. So that's why we are creating a dummy interface. Because of this reason only, like if you use a certain uh, address or interface, then maybe that it would happen that some services are listening on that port. Okay, so because of that, we're just creating a dummy interface for this functional test to work.
Yeah, like we can like simulate a situation where this functional interface that we have created, it
Hmm.
is like we can simulate it to be busy, and
Hmm.
then like how the test will, like how the system will handle when this case happens, would be like something
Hmm.
interesting
Interesting.
to look at.
Yeah, yeah, that would be interesting.
I think
I
this
think.
situation is handled by operating system. I think that's not the Bitcoin core stuff. I think the operating system take cares like whether to assign new ports or IP addresses. I think this can be handled by operating system, and then it will return some kind of error, and then Bitcoin node catch that particular error and says to the user that like this port can't be usable like this. I think.
Yeah,
Yeah,
but
yeah, yeah.
we have a hard check on what the address of the port is, right? uh, which won't be like, if the operating system like tries to change it, the like the process would be running, but since we have a hard check, the test might fail. So
Yeah,
that's what
yeah,
I'm
yeah.
considering.
Yeah, I think the test should fail. Like if you're using some
Yeah,
different
I
address.
definitely feel like
Like some processes also use like relative port names, kind of something like that,
Hmm.
which in that case it can like be like handled properly.
Yeah, yeah, yeah. That I think we can add this in the issue as well. If the certain port is being used
by
like
changing
for
the
testing.
lines of code. I think.
Yeah, we can add that in that issue. That would be a good discussion. Yeah. So any more question?
Yeah, that's it from my side.
Yeah, maybe we can move to the questions I guess you might have prepared for the participants.
Uh yeah. Just a second. If we can find some interesting comments.
Yeah, the only thing I found interesting is that the issue was found on Windows 3.11.
Yeah, actually.
That's amazing.
This one is interesting. So it looks like discover skips loopback interface intentionally. It is done by this line of code. Once it's coming, then maybe the test routable later setup. So basically, let's see the code first. Okay, if the interface is loopback, then it will skip. Okay, and yeah, I mean, loopback interface. It's like the interface that would be only accessed by your own system, and that would only listen uh, by the services of your own system. I mean, that interface is just confined locally, like not external services can access that or route in that interface. That's the loopback interface. And the discover, basically the get local address. If it's found that the interface is actually loopback interface, then it would actually keep that interface because we don't want that interface. Okay, because the external peers or services won't be able to listen on that port. So that's what we saw in this test as well. We were seeing we could also see some like it was just trying to go on line 286 again and again. So maybe in that in that process we just it the like Bitcoin just found some loopback interface. Okay, and that was interesting. And yeah, rest all are reviews. So yeah, we can just go towards the question. So, what do you think? What are the potential implications of not discovering network interfaces? Any answer you'd like to? Anyone want to try?
Yeah, this can create situation like we would like some particular port to be handling uh, our like communications that would be doing with other nodes, and it might like redirect to some other nodes or might not do it at all. And then if like some error or something happens, like we are not getting some messages, etc., or like we're not getting any errors at all, we won't be able to find out that it's our node that is having something, like our node is having some issues.
Yeah, I agree. If we don't discover the possible what all interfaces are there, then we won't be able to find whether that interface is actually there or not, or if that interface, if users explicitly define some interface, then if the discover won't search that interface, then how it would bind to that interface. So yeah, that's the some potential implications. And any more answers, like if you guys have it? Okay, so let's move to the next question. So what does feature bind port discover.py test? Anyone who has
So
done it?
yeah. I think the new code written in the feature bind for discover it checks like whether you are explicitly typing the bind or not, and then checking the result, or if you are explicitly type the bind 0.0.0.0.0, and then the port, and then this will check whether the discover function is invoking or not, or if you are typing the a local host in IPv6 form, like the colon, then it's checking like whether the discover function is not invoking and all. And it's also checking for the onion routes, and checks for the if it's invoking or not, I think.
Hmm. Yeah. Any more answers? Okay. Yeah. That was the main idea behind this, the functional test, like whether if there is some bind, if the user specified some bind conditions, not conditions, I mean the interfaces, different interfaces. Okay. Then if discover is invoked or not. That was the main idea behind this, the functional test. So next question is, yeah, what is the role of a discover?
Sure, I think the discover finds all the local IP addresses and port in your system, like whether it's a Unix or a Windows. It all search for the local addresses.
Yeah, makes sense. Yeah, just searches all the IP addresses or network interfaces and ports available. And the next is, why was the discover not invoking before this PR? What I meant to say is that why, when we specified 0.0.0 or double colon, then why wasn't it the discover function invoked? Any
Yeah,
answer?
because of insufficient checks, like when like the call for discover was being like, the flag that was like being used to call the discover function, it was not being like triggered because the uh, like the checks for the like network interfaces that we like created were after the discover function was called and not before, which was supposed to happen.
Yeah, yeah, yeah. That's actually correct. The flag was basically bind on any. Yeah, this was the flag. This is the bool flag. If it's this was false because this thing wasn't actually empty because we have already given 0.0.0 and double colon. This would become false, and eventually this bind on any would become false. If bind on any is false, then discover is not actually called. And yeah, and the next one is uh, what is the significance of the loopback, or basically the dummy interface setup in this test interaction instructions? You can just skip this loopback, just focus on this, why the dummy interfaces setup was created.
Yeah, basically like just to don't mess up with our own services running on our like OS and used a separate set of dummy like interface to work with and test with like test the PR with.
Yeah, makes sense. Just
Yeah, we
for
can assign like different IP addresses. Like you can split the IP addresses range by providing the subnetting mask, like as mentioned in the code, not code like in the PR answer. Like you can create a single or multiple addresses, and you can test them separately using the virtual interface.
yeah,
Yeah,
just
nobody would like to see the like current like interfaces that we have and working every time. I'll have to like check like test for it and then specify some other like addresses for it. Cumbersome task
Yes,
to
we
be
don't want to
done
mess.
again. Just don't mess with it.
yeah, yeah, just it's the interface don't collide while testing. That was the main idea. And yeah, the next one is what debugging techniques would you use to verify the behavior of Discover? The one was I just show you with LLDB or DBG. Uh, anyone has any other in mind?
Yeah, GDB works fine, I guess, also with this.
Yeah.
And also then we can probably use the age-old debug statements to it.
Yeah, yeah. Log printf. And I'm not sure. I'm not familiar with fuzz testing. If anyone is familiar, then like whether fuzz testing would verify the behavior of Discover. I'm not familiar with fuzz testing.
What first test would do like in the case the checks were like insufficient, right? They were
Yeah.
then like previous cases, it it there were two like cases added, two specific addresses to check for it, and
Mm.
if like we set the fuzzer to check that for this specific set of like inputs it should fail and further it should pass, and probably yes we could have used it like manually, like since in the issue the person who like created the issue did it manually just to make sure that these set of inputs are being currently like correctly tested. First test would have like done it on the first day itself if there were correct number sets of like assertion statements or like uh, checks that we would have used.
Okay, makes sense. Yeah. I
But
think
like currently, I guess the first testing is only for the CPP side of things. There is no. I guess, yeah, I'm not sure, but I guess fuzzing is currently only for CPP side of things, only on the like core, not on Python side.
yeah. So I think we can maybe verify the behavior of discover using first testing. That would be interesting. Yeah. Anyone has any questions related to this PR? Yeah. If you don't have, then yeah, I think we can end this. Uh, Thank you everyone for joining. We'll see you
Hey,
soon.
thanks, you, Vic, for hosting. I also don't have any questions from mine because I did not get an opportunity to even open the PR. I just came in front of my laptop at around 7:45 and I showed up for the session. So no questions from mine, but yeah, you did a great job, and thank you everyone for joining and making the session interactive. And looking forward to meet you guys in a couple of weeks from now.
Yeah. Yeah. Thank you everyone for joining.